we're doing some engineering homework on this Saturday. Let's go. Yeah, no, how are we going to do this? Oh, wait, what if I do this? Oh, yes. So I don't have to show my room. Yes, ma'am. So we'll just have to be like that. Oh, to my back. There we go. I think that's okay. So I'm just gonna share the screen, the entire screen. And how can I lose the background? I don't have access to that feature. What does that mean? I don't have access to that feature. Pop out dashboard, channel. I see. Well, looks like we're just gonna have to do the green background then. Hold on, I'll be right back. There we go. We just had like a shirt underneath. Didn't know why it was so hot. That's much better. All right, so let's do this. We have a lot of work to do, but we got to do it. You know, whenever I don't want to do something because it's a lot of work, I just remind myself what the Navy SEALs have to go through on Hell Week. It's like 5.5 days of like 3 hours of sleep, hallucinations, a bunch of hard work, cold water, hyperthermia. So yeah, there are tougher things to go through in life, and we're not there yet. So we need to prepare ourselves. And right now, we have this to do. So I'm just gonna get my water because water is important. If you think I make a lot of noise drinking water, well, you can type that down in the comments, and I'll listen to the advice. Let's see. I'm trying to. So what's my goal right now? So I know I want like this extra credit. I mean, my grade is pretty good. I don't need extra credit, but I guess more points would be kind of cool. Yeah, so I just need like a draft right now. Just a draft. So what I will do is simplify the notes, because why not? Notes are pretty important. So I'm just gonna put this on this. Oh, whoops, yeah, here. Let's name this UML automation models. Okay, well, let's begin. Let's begin simplifying these notes. You see, the tough part about this class is that it's really vague. There's a lot of ambiguity in here. I mean, it's not very like specific. So what I like to do is just copy and paste all of these instructions, put that, and as I go reading through them, I just simplify it in my own words. I don't simplify them drastically because I don't need to, but I just try to get rid of the ambiguity and like those filler words that are unnecessary. But I mean, even though this class can be sometimes confusing or annoying, I know that this class is overall pretty cool. It's a good skill to handle doing your homework with ambiguity. So let's do this. It's enough talking. Yeah, I wonder who that one person watching is. Well, it's good to have you here. But let's begin. So we have these. Uh oh, dude, my back. Oh, that kind of hurts. There we go. Like, is there no way I can? Sorry, before I begin locking in, is there no way? Why don't I have access to this? Why can't? Oh wait, edit. Oh, edit settings, customization. No, I just want to get rid of the background. That's it. It's fine. It's not a priority right now. So let's do this. So yeah, I don't think I need that. Automation systems. Uh, gotcha. Good to know. Concise, simple, hot. So let's put some bullet points in here because why not? Cool. Okay. Now, what we need to do is think about what rescuers, pilots, and victims would need from your what? I'm sorry. I just got confused. Oh gosh, what do you need from your my bad. I'll be back. I just need to get to the bathroom. There we go. And we're back. Okay. I like that. And the thing is that as we're writing our notes, we kind of understand what's going on. Okay. So be creative. Be creative, guys. I don't understand. Do they want us to demonstrate this? Or is it just acceptable and then like it's optional? All right. It is cool. There we go. Beautiful. Okay. And are they giving us like an example? For instance, you could use the uh here. Let's do that. Dude. Uh okay, cool. I see. Two input sensors and two output reactions. I see. Okay. I see. Okay. I'm guessing those are two input sensors. Okay. Use case. Oh, to fully describe your system, you will need to complete a use case diagram, a sequence diagram, and an activity diagram for each feature you design. I see. All right, so let's read through all of this again. One important subsystem that will be addressed is the design of your aircraft's automated systems. Before you build and program your automated feature, you must model the uses and behavior of the feature using UML diagrams. Think about what rescuers, pilots, and victims would benefit from your aircraft using automated features using sensors. Be creative. It is cool to demonstrate your automated feature as a proof of concept design. This means you can show your automation in a simple form and explain through your design work how this automation would be incorporated into the aircraft. For instance, you could use a button to represent a seat pressure sensor. A seat pressure. Oh, I see. Okay. That turns on an overhead reading light. Turns on an overhead reading light. Overhead reading light for a passenger automatically. Oh, I see. So that means if I if it's dark and I come and sit down, but it's dark, it would be cool if as I sit down, there's a light on top of me that would just automatically turn on. So that if I grab a book, I can just read it without having to turn the light switch. That's kind of cool. uh you wouldn't need to design the seat and overhead structure in the simulation. Gotcha. Yeah, I think one of the things that the lecture emphasized is not showing how your idea is going to be executed, but just focus on the objective. For example, yeah, don't focus on designing the structure that is going to hold the what is it called, the overhead reading light, but just make your objective clear that you want an overhead reading light. I think that that's what they want. You wouldn't need to design the seat and over. Yeah, the most important thing is to think. Okay, here I'm just gonna. The most important thing is to think about what your customer would want to know about and design. Oh, the most important thing is to think about what your customer would want to know about and design to make the user's lives easier. Right, always appeal to the user when you're creating your design. A truly entrepreneurial engineer always considers how the design can affect the users first, then worries about the technology involved to make that happen. Beautiful. Mwah. Dude, this prompt is now crystal clear. For this subsystem, you are required to design automated features that include at least two input sensors and two output reactions. My bad. For example, you could use a button and a temperature sensor in your design to relay information that controls a series of lights and a buzzing alarm. These combinations can work together as a part of one large system or act individually as two separate automated features. I see. To fully describe the system, you will need to complete a use case diagram, a sequence diagram, and an activity diagram for each feature you design. Remember to specify who are the users and think about everyone slash thing that could come in contact with this design to ensure you prepare for any rainy day cases. You will use these models later in the project to program your automated features. Beautiful, beautiful. Now we just need to simplify the instructions. Here, let's go back. Um, and that's it. We just need to do the instructions, and then we can actually on doing what we need to do. I see. Okay. Yeah, and I mean, when we create a memo, we're just gonna follow the instructions. Yeah, so no need to go back to the browser. I'm just gonna live here now. Okay, cool. So I believe we can see these instructions as a series of steps. So this will be step one, and we can make this bold. Descriptions of automated feature. So we will begin by describing our automated feature. Summarize the large scale vision to be implemented into your aircraft using your automated feature. I mean, I haven't chosen anything yet, but it looks like I do. It looks like I have to. What is the purpose of this feature? Here, now let's put them in points. No, no, no. Sure. Wait. What is the purpose of this feature? Why do you feel this is a necessary need? Okay. Who will benefit from this feature? Gotcha. Okay, okay. Yeah, so a similar questions I see. How does the feature connect to the customer's need? Okay. So it looks like we're emphasizing on the customer. Cool, cool, really cool. What should happen if everything follows the appropriate uses? So I think the class wants me to see this as like a sunny day scenario where everything goes according to plan. Yeah, the appropriate uses. Yeah. Is it possible this automation could be used or abused in any way against your intentions? I think so, right? Yeah. What sensors do you plan on utilizing? Okay. What is the desired reaction to your system? This is your chance to explain how your aircraft can benefit from an automated feature to help with search and rescue efforts. Okay, cool. Cool. So, a description. I shouldn't sweat on all of that. If I have a solid idea on what my automated feature is, I think we should be good. So now we have to insert a picture of your use case diagrams for your design. Oh, dude, my back. Why is it doing that? Oh boy. Wait, what happened here? Whoops. It's not tab. Come on, dude. No. Make sure you include every potential user interaction to consider weather, animals, or maintenance. I see. This diagram, oh, I can do that there, but why not there? Bro, what are you doing? Oh. Alright, I know I shouldn't focus on this, but that's what I will do. Why is this not working? If I do this. Bro. Okay. This diagram should not show how your feature will work, but needs to explain the relationships between what the user can invoke and the response they should see. Be careful to use the include/extend relationships appropriately when describing additional use cases. I see. Yes. After your diagram, include a small summary explaining the users and their roles in the system. I see. Okay. Here's gonna. So, step 3, sequence diagram. Insert a picture of your sequence diagrams for your design. So, this was insert a picture of your case diagram. And here we have to do a sequence diagram. Oh, gotcha. You can't do tab either. What is going on? We can do everything tab except this. Dude, stop. Oh. Hold on. I think I know how to. Also, here we have to do. Why? Why is the 2 not working? There we go. It's fine. All right. We'll just put a 1 there. So, now. This should show the chronological relay of messaging that starts with the user invoking an action and ending with the user seeing a reaction from your system. Make sure to include any processes within the timeline where you predict that your automated program may need time to perform an action. Yeah, I remember that. If you have situations where a decision is made based on the state of the sensor, draw a sequence diagram. Gotcha. For both slash all possible cases. You may do this all You may do this all in one diagram as long as you appropriately label which section of the diagram belongs to which situation. After your diagram, include a small summary explaining the sequence of the events that occur given your situations. Beautiful. So now we have step 4, which we sadly have to name one. And then here we have to insert a picture of your activity diagrams for your design. Here. This must show the full behavior of how your features will make decisions based on the multiple input sensors and all possible values that could be attained by that sensor. Make sure to do your research with your chosen sensors to see what sorts of values can be reported. Okay. This diagram must show a path for each possible input value from each sensor. Okay. Do not forget any rainy day situations. Also, make sure that the user does not end up in an infinite loop within your automated program. After your diagram, include a small summary explaining the flow of events that occur. So, ladies and gentlemen, here are all the instructions we have. Now we just need to begin. Okay. Um. Yeah. Mostly, I know everything that they're talking about. I'm just gonna have these videos open up in case I forget the diagrams I'm supposed to do. Uh, abide by our community guidelines. Will do. I will make sure to abide by the guidelines. Gotcha. Now, let's see. I mean, I'm not missing anything. Oh wait, and this is our assignment I have to do. Yes, but that can probably be done tomorrow. Okay, so let's begin. So looks like we have to choose an automated feature. Ooh, okay. We have to choose an automated feature. What automated feature should we choose? Okay. So to open up all my previous memos. Here, I'm just gonna open up all the memos I've done in the past. Whatever. So opening up all of these. So this was our first. Okay. I don't think I needed that one, do I? Yeah. No. Hold on. Oh boy. Automated feature. Okay, I see. Always love this one. Yep. So, summarize the large scale vision to be implemented into your aircraft using your automated feature. Let's see. So, to give some kind of background, my aircraft that I've designed up to this point is cattle oriented, and it focuses on prioritizing cattle during disasters. I have already designed the payload of our design. Mm, well, I should have done like like a fire extinguishing. That would have been cool. Anyways, so we have, let's see. So we're doing cattle. So yes, I mean I was thinking about doing a ramp. We could do a ramp. I don't know if strings would be a good idea, but okay. Let's see. Hmm, that's a great question. Yes, that is a great question. What should we do? Let's see. Let's see. Um, yes. Okay. We're gonna do a ramp. Let's do this. So, where are we? I don't know. Wait, no. Mm. Uh, it's a good. Oh, hey, another person joined our stream. What's up? It's good to have you here. The connection is unstable. I'll be quiet, I guess. Is it the connection? Oh, cool. What's up? How are you? Welcome to the live stream. It's good to have you here. Right now, we're just doing our engineering homework. It got a little boring, but since you wrote something, now it just got a little fun again. I think in here. I'm trying to find a good word to convey the idea of, I don't know, letting a ramp out of like a storage area and putting it on the ground. I don't know what a good word for that is. Should I just ask like a chat GPT or something? Here, what if we just ask Copilot? It's this. Oh, a chat about the Roman Empire. Those Punic Wars were insane. However, where were we? What? Oh, how about this? How can I convey this idea better? In the ground. How about that? If you're trying to describe the act of releasing a ramp, releasing, I like that word, releasing, letting the ramp drop into place, releasing the ramp so it settles on the ground, anchoring the lamp. Whoa, good ones. Yeah, so I guess I could do something like, since a ramp can easily accomplish this week's memo will focus on, let's see, um, ramp lowering and placement. Okay, here. What if I just copy this sentence? Uh, I like that. Ramp deployment and ground placement. Yes, that's beautiful. On deployment and ground placement automation. Well, that sounds good. Wait, yeah, ground placement. I think that's good. Perfect. In fact, yeah, I'll just keep a Copilot there in case we need more help. Which engineering, like CS, mechanical, which engineering branch are you in? Well, I am doing intro to engineering right now in ASU. So this is not really centered in anything right now. I mean, I'm a computer science major, so yes, I'm in CS. Yeah, computer science. Are you in any engineering branch right now? Here, okay, cool. Since RAM can easily accomplish this, this week's memo will focus on ramp deployment and ground placement automation. Beautiful. That's beautiful, bro. I love that. So we have summarized the large scale vision to be implemented into my aircraft using automated feature. Okay, a kind of. I haven't exactly done that. However, let's see. Automation. Gotcha. So here, throughout the lecture, I took some notes on all the types of sensors they have given us. So I'm just gonna emphasize on these labels over here. Um, should I make this bigger? What? No, no, no. No need. I'll just put a. Sorry, this is a heading. Types of sensors. So we have a simple sensor, we have a photoresistor, we have a temperature sensor, we have an ultra distance sensor, a motor sensor. Oh, sorry, PIR motion sensor. Sorry, motion sensor, not motor. And then we have like an LED. Then we have like a motor sensor. It's gonna servo. Okay, I think maybe that meant to say service. Well, I'm not exactly sure. However, that's okay because that won't stop us from not continuing this, from continuing this. So we have all of these. In fact, maybe we can put these like in a table. Yeah, let's put this like in a table right here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Insert table, columns. Let's have 3, and rows. Let's have 9. So here, so this is going to be a simple sensor. This is going to be a photoresistor. This is going to be a temperature sensor. This is going to be an ultrasonic distance sensor, a motion sensor, PIR motion sensor. This is going to be an LED sensor. This is going to be a motor sensor, I think. A servo motor? Yeah. I got a. And then we have an LSD display. So these are the ones they talked about in class. Now let's add our a description. Uh, measures if something is on or off. Requires users to only have 2 options. Measures. Okay. Here, let's and here we have, hold on, it's gonna do no. There you go. Cool. Well, I think we understand right now. Oh, here, wait, hold on. Let's just finish. All right. That's a little bit how it's going. What's going on? What major do you study? Well, I'm doing. I'm in computer science right now. Hello. Huh? I thought it would echo or something. Cool. So, mm, gotcha. Okay. Okay, I think I see. Let's see. Hmm. Although the on ramp deployment and ground placement automation. Uh, is there anything we want about this, about our ramp? Do we maybe want to know where we can position and positioning? Yeah, I guess that can be important, and positioning as well. Um, I mean, I guess I could use like a motion sensor. No, no, no. How about like a hmm? And is that a servo, a motor? Wait, here types of sensors and examples. Let's see. Let's see. Servo motor. Yes. The display. A display. Okay. Okay. So I think we were good. Um, so then, let's see. So, oh wow, dude, that's tough. To extract and board cattle from the ground. How about, let's see, what should a ramp do? Our ramp. Uh, dude, chin. So here, let's ask. Yes. Okay. Um. Cool. No, no, no. That's good. Structural strength. Perfect. So I think we have two things that we should watch out for. Um. So the first case, a sensor will be used in the ramp will be uh will be no 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 a sensor will be used f- for easy ramp. No, no, no. Will sorry, no. The first case, no, will be used during ramp deployment, making sure the ramp is released at the correct time, uh, and not released because that's also important at the wrong times. Yeah, this is really poorly worded, but we can fix it later. The idea is the most important part here. Then we want the second sensor will be used after the ramp has been released and when the ramp uh, needs to be locked into the ground. Since cattle are heavy and considering many of them will um, will board the aircraft at a time, the ramp must must know or fine. The ramp must lock into the ground when cattle is approaching. I guess I'll say. Beautiful. So I think this is a good start. It's incredible how tired thinking in these cases makes you look. We've been streaming for 1 hour. That's insane. I don't even know how that's going on. What else we got? Well, my friends, I guess that's it for right now. I'm just going to end the stream right here, and I'll see you all next time. Thanks for joining.